Hi guys, welcome back to my channel. Initially, in my video that I uploaded to you all about mechanics practical, based on my research, I noticed that I make use of a retort stand in the video. So for further research that I make on this video, I was able to get the real solution to the specimen given to us for this year's Waec 2022. And one of my research is that we noticed that we only want to prove the principle of moment as was done initially, but just that in a different way. We are asked to provide a mass angle. We are asked to provide a set of masses, and we are asked to provide a string. We have to provide a string, a mass angle, a set of masses. Then we have to provide a fulcrum. Let's take it a fulcrum, or we call it what? A knife edge. So we have to provide a fulcrum or knife edge, a string, masses, mass angle, and weighing balance. Now, what is the function of this thing? Whenever you are asked to provide each of these experiments, note that you only want to verify the principle of moments. Now, and according to the principle of moments, it states that the sum of the anti-clockwise moments must be equal to the sum of the clockwise moments. Now, the experiment that we're able to get for today is shown on the board based on the real practical. We notice that it is gotten from your past questions. Now, but what I'm going to be showing here is that I try to formulate the readings that is here, just that what we are given in the past question is not the same value here, but the same experiments, but not the same values given in that same year in past question. Now, before I start today's class, I would like to thank you all for helping me to get to 700 subscribers, and I hope to get to 1,000 subscribers with the help of you all. Thank you very much, and don't forget to subscribe to my channel, and also click on the notification bell to receive notification whenever I release a video. Thank you. Now, what are we given today in the experiment here? We are asked to provide, it said, you are provided with a uniform meter rule, a knife edge, and a body M. Now, you see this body M here is denoting, this is my mass, my angle is provided in this place here. My mass angle should be provided in this place here. Now, the function of the mass angle is to be able to hang each of your masses in this place. Now, what we want to do in this place, the only thing we want to do here is that we want to vary the distance of that mass from the knife edge. What will be the distance x of the masses from the knife edge? That's what we are to vary in this place here. And also, we want to determine the weight, the mass of this meter rule in this place here. But how do we go about it in determining the mass of this meter rule from this experiment? That's what we want to determine. Now, from here, they said you are provided with a uniform meter rule, a knife edge, and a body M of mass 20 gram. The mass of the body provided initially to us is 20 gram. Now, what is my apparatus? Initially, I'm given the knife edge. This is my knife edge. This is my mass M that we have to provide. Although this is our mass angle, this is my mass angle. On this mass angle, I'm going to hang my mass M on it. And we also have to provide a knife edge. This is my knife edge that I want to use to balance this. Now, initial experiment said by means of a thread from 1.0 centimeter mark. This is my 1.0 centimeter mark on the meter rule. We have 1.0 centimeter along here. This is my 1.0 centimeter. We are asked to suspend on the meter rule, balance the loaded meter rule on the knife edge as shown in the diagram. That means what you are seeing here, try to perform the same experiment. Now, for 1.0 centimeter, place your mass angle with the thread on the what 1.0 centimeter mark as shown, we try to move it. Make sure that what this thing is well taught to this place here, so that there will be what movement of this thing from one point to another. Now, the next thing we have to do here is now to balance it on the meter rule. We are going to balance in such a way that we will be having the meter rule will be balanced horizontally. But how do we balance it horizontally? Watch, if I place this thing here, I notice that there is kind of movement. Sorry. There is a kind of movement from one point to another, showing that it is the weight of this meter rule is towards this direction. Then I can easily change this by moving it until it will stand horizontally like this. Sorry, trying to balance it. Now, from this point here now, here we can have our balance point at this exactly 45 centimeter mark on the meter rule. Now, the meter rule is balanced at exactly 45 centimeter mark in this place here. This is the balance point of the meter rule. Now, on getting to the balance point of the meter rule, we can easily find the value of x. What is our value of x? Our value of x is the distance from the balance point of that meter rule to the point x. To the constant value of your mass, which is hung at 1 centimeter. So, if the meter rule is balanced at exactly 45 centimeter, then the distance of the balance point from this mass is equal to 45 minus 1 centimeter. Why? Because the mass is hung at 1 centimeter mark. So I'll be having 44 centimeter. Now, as you can see on the board, you can notice that we have the observation of our experiments that is performed. So for here, when the mass is 20 gram, we notice that the value of our x is 44.0 centimeter. So how do we get that? It is always the balance point minus 1 centimeter. I'll be having this exact value here. Now, next they said we should try to determine and record the value of x when the meter m is balanced at equilibrium. Evaluate 1 over x. I'm coming to how to evaluate this. The next thing is we will repeat the experiment for values of m. That means when my m is 40, 60, 80, and 100 gram. Now, the only thing I'm going to do is that I want to make sure to explain something to you here. This mass angle that I'm using is having a mass of 20 gram. The mass that is here is 20 gram. Now, if you want to add your mass, you are going to put into consideration the mass of this angle, which is 20 gram. Now, from this point here, I already know that when I want to perform it, I make use of this only this mass angle to represent my 20 gram. Now I need 40 gram. The only thing I need to do is to add a 20 gram mass, which is this, to it. If I add my 20 gram mass exactly into it, this is making 40 gram. Then I can find my new balance points of the meter rule. Now to get the new balance point of the meter rule, let's try make use of another points. I have here, it is towards this direction. I can bring it along this direction to get the new balance points. Now, from here, the new balance point of the meter rule is, sorry, okay. Now, the new balance point of the meter rule is exactly at 41 centimeter. This is the balance point of the meter rule. When the masses is equals to 40, the only thing I can get is that to get my x, it will be equals to 41 centimeter minus 1. Then I will calculate, that will be not my x from the board. My x is equal to 40 centimeter. The same thing, I can find the mass of 60. How do you calculate it? by only adding a mass of 20 to this. Already we have 40 grams. If I added 20 grams to it, then one thing I want you to notice that as you are adding the mass, when there is an increase in mass, there is a decrease in distance. Or sorry, the value of x will be decreasing. So as the mass is increasing, this value of x must be decreasing. That is one way of evaluating it without even performing it. When you take the first reading, second reading, and third reading, you can easily get the fourth and the fifth reading by just approximation. Now, from this first reading, we notice that we have 44. Second reading, we have what? 40, which shows that there is a decrease in 4. That means the difference between first reading and second reading is what? 4. That is the difference between it. So the third reading should also follow the same manner. This will what help you to manage your time. Now, I have the third reading to have 36.5 in centimeter. The fourth reading is having 33.5, while the last reading is having 31.5. So you can easily approximate your reading from here, whereby you can have maybe 34. If I approximate this, I'm going to be getting 34. If I approximate this, I'm going to be getting 32. Altogether, that is for my reading. Now, we've been able to get the value of x for this experiment, which is shown in the what? On the table above. Now, the next thing that I want to calculate is how can we find the value of x? We have to evaluate 1 over x. Now, how do we evaluate the value of 1 over x? This is quite easy because it is just reciprocal. Now, we are talking about the reciprocal of x. Now, if my value of x here is 44, then the reciprocal of x, that is 1 divided by 44, I'll be having this 1 over 44, which will give rise to 0.023. 1 divided by this, I'll be having 0.025, and so on. I'll be having what? 0.030, 0.032. Now, when I want to perform the experiment, I can give it in, it is advisable. If you want to perform the experiment, you can take your reading of x value in 2 places, whereby I'll be having my initial x1 and I can have my initial s2. Now, if I'm taking this reading, it's just to avoid error. If I'm taking the reading of x in 2 places, for example now, my initial value of x is 44, I now need another value of x to be equal to maybe 43. Then I can find the average value of x, x1 plus x2 over 2. We can also employ this by looking for the average. Altogether, just that if you are to write your precaution, then you must include that in your precaution that two readings are taken for the value of x to avoid error. So you take what? 2 readings to avoid what? Error. But here I'm not using 2 readings, I'm only using a single value of x. So I'm getting my value of x, calculating my value of 1 over x. Now the next thing I try to do is to convert my value of 1 over x into standard form. Because I noticed that if I want to find the scale of this graph, the graph of this thing, it might look somehow tedious for me to calculate the scale. So the best thing for me to get an easy scale to use, the best thing for me is to convert this into standard form. And I employ one of you to do so. Just that if you want to write in your graph, you are going to put there that you are converting it to a standard form by multiplying by 10 raised to the power minus 3. So if I convert it to standard form, I should be having 1, 2, 3, which is 23.0 times 10 raised to the power minus 3, like that 0.25, 25.0, 27.0, 30.0, 32.0. This is for the experiments. Now, another thing I want you to note in your observation, if you are taking your reading, please note that your units should be beside the quantity. Mass m, the unit is gram. Distance x, the unit is centimeter. Distance 1 over x, the unit is centimeter inverse. And so on and so forth. That is for that. I think the next question here now that we are given, we've been able to find calculate the what? Readings of this experiment. Now, the next question we are asked to do here is that in each case, determine and record corresponding value of x and this, okay? Calculate your reading, then plot a graph of m on the vertical axis and 1 over x on the horizontal axis, starting both axes from the origin 0, 0. Now, listen carefully. Sometimes you might not be given the origin of your graph, but you should know that if you want to plot graph in physics, your graph must always start from the origin of 0, 0. Every graph in physics must start with the same origin 0, 0. where this initial 0 here represents the x coordinates, while this one represents the y coordinates, whereby I have the abscissa and the what ordinates. That is what it represents. So if you want to plot your graph, if you omit this origin, then there is a deduction in mark. Altogether, that is another thing I want you to know. Now, I'll be showing you how to plot the graph of this experiment in an easy way. Thank God that we've been able to what? Write our value such that we can easily calculate the scale to use for the experiment. Altogether, now let's jump into the what? Plotting of graph of this experiment. Now, let's now take a look at how to plot the graph of this experiment. Now, we have to plot the graph of n on the vertical axis and the graph of 1 over x on the horizontal axis. Now, what kind of scale can we pick for this? If you want to pick your scale, you take a look at the lowest value and the highest value. From here, we have the lowest value as 20 and the highest as 100. Now, I can easily use 10 centimeters, 10 gram. Altogether, that means the difference between my scale should be what? 10 what? Gram. Now, how do I do this? The first thing I need to do is, I want you to understand that on this graph board that you are seeing here, each of these things is 2 centimeters. The distance from here to here is 2 centimeters. So we can easily make use of 2 centimeters to represent 10 gram on this axis. 2 centimeters to represent 10 gram on this axis. But please note, don't write this thing out in your graph. Note that, just notice that they're going to understand the kind of scale you're using from your scaling that you put in this place. They will understand the kind of scale you're using. So you don't need to put this inside your gram that I'm using 2 centimeters for 10 gram. It doesn't need that. Now, also on this axis here, I'm using, see that my highest value here is 32 and my lowest is 23. Not something that you want to plot your graph. Make sure that your graph contains at least 80% of your book. Now, some of you are going to be doing something of this kind that we are just going to draw from here. Let me say this is the graph book. You draw to half here, then you fill it. You now pinpoint as it's like this 20, 40, 50, 60. You are going to write it out like that. Then you started plotting. Actually, you are going to get your mark, but they will deduct mark from it altogether because you're just looking as if you are bringing the exact value into the graph book. Now, from here, what will I do? I have my scale here. Here, I'm making use of 5 gram. Sorry, I'm making use of 2 centimeters to represent 5 centimeter inverse. That is what I'm trying to use here. Don't forget that the unit here is centimeter inverse. So I'm trying to use 5 gram, 2 centimeters to represent 5 centimeter inverse altogether. Now, how do we go about this here? Let's try to merge. From here, we have 20 gram to what? 23.0. How do I read my 23.0? Note that I can easily read this. If you have to use 5 centimeter and 5 units, note that 2 buses, we have 10 buses here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Abi? Now, note that 2 buses represent 1 centimeter inverse here. This is 1, 2, 3, 4, 5. 2 buses. If we count like this, let me say like this is 2 buses from here to here, it represents 1. Another 2 buses represent what? 1 altogether. So if you want to count this here now, it is quite easier for me to count. Why? I'm not using 10. Now, let's try to merge 20 to 23.0. Now, 20 on the mass axis. Now, if I have here as my mass axis, this is 20 to 23.0. I need to go and look for my 23. How do I get my 23.0 on the x inverse axis? From here, I have 5, 10, 15. This is my 23. My 23 should be somewhere here. This is 20, 20, 21. If I count like this is 20, from here is 21, 22, 23. This is my 23 here. From here to here, this is my 23. And I'm going to 20. So I can use asterisk like this to indicate. So this is 20 to 23.0. That is number 1. Note that. Then the next one, you have 40 gram to 25.0. 40 gram to 25.0. This is my 40 gram going to 25 exactly. This is 20, this is 25. Now, taking it down to 40. This is it here. By putting asterisk like this, I'm trying to make use of different markers so that you can see it very well. So I have 40 gram to 25.0, and also I should be having, the next one is 60 gram to 27.0. 60 gram to 27.0, this is 60 gram. 27.0 should be located somewhere here. Okay, let me try to put in 60 gram. Yeah. If here is 25, now from here to here is 26. From here to here should be 27. This is 27.0. 27.0. That is my 27.0. Now, and the next one is now 80 gram to 30.0. This is my 30 to 80 gram. Now, 80 gram should be located somewhere here on 30.0 axis. This 30.0 to represent 80 gram. And the next value is now 100 gram to represent 32.0. Now, if here is 30, okay, let's locate 100. This is 100. Yeah. If here is my 100, then I have 30. If here is 30, this is from here to here is 31. This is 32. So this is my 32.0. Now, you have gotten the 3 points. Now, you don't need 3 best line of fit. You are going to get 3 points that has that is on a straight line. Now, we can easily get that by taking our ruler, finding that 3 points that will be on a straight line without any curve. I should be having these 3 points here. Now, this point that is here is exactly on a straight line without any curve, which is this, this, and this. So I can easily join them together. Let me use blue pen to indicate that. Now, this is my points. This is my points. Now, I should have this to get to the ground. This is my points. Okay. I have this showing. This is it. Now, this is my points. This is my straight line. I have this straight point here. Let me try to remove all these unnecessary lines. So this is my 3 points. This is my 3 straight points. 1, 2, 3. Now I've gotten the straight line graph. The next thing that we can get from the graph is to calculate our slope of the graph. How do you get the slope of the graph? Just pick any point on that straight line, then use to calculate your slope. If I pick this point here, let me say this point here, and I try to pick somewhere that will make my work easier by picking somewhere here, but make sure that your slope should be a little bit larger. So if I pick this point at this point here, then I can also pick this point here. Now I'm going to join the point together by joining this to here. Then bringing this downward to touch here. Now, here, whereby this is my point, I can find the coordinates of this point here. What will be the coordinate of this point? The coordinate here simply means what is the distance of this point from the m axis, and its distance from the x inverse axis. Now, if I cross-check like this, the distance of this point from this point here is 90, which is my x value. So the distance from here to here is 90. Sorry, this is my y value. While the distance from here to here is, if I trace it downward, that is 30. So here should be 30, 90. That is my x is 30, while my y is 90. Now, I can also find this point here. You can calculate here. This is my second point. So what will be the distance from here and from this side here? I think I have from here like this. If I trace it downward, I should be having 24. So here is 24, I have 24. While if I trace it to this direction, towards here, I should be having 30. So here I have 24 in the X and then 30 in the Y. 30, 24. So I have 24 and 30. So this is the coordinate of the axis. We have 24, 30. Now we've already gotten our coordinates. Now the next thing is now for you to calculate the slope of the graph. How do we now find the slope of the graph? I can easily find the slope by writing my slope in this place here. The slope of the graph should be equals to, my slope will be equals to this. Now, if I take a look at this here, I can easily say, okay, the distance along this direction is, this is my m, then I can take this as change in m in gram. While this one is my change in x inverse, this one is my change in s inverse, then the unit is centimeter inverse. So change in m and change in x inverse, the unit is centimeter inverse. Now, my slope should be equals to change in m vertical all over horizontal, which is change in s inverse. Now, my change in m should be equals to 90 minus 90. Your m, this is initial m, sorry, this is my initial m, 30. My final m is 90. So change in m is final m minus initial m. That is 90 minus 30 all over. This one should be my initial x inverse 24. My final is 30. That should be 30 minus 24. Now I should be having something of this kind. That is 90 minus 30 should give rise to 60. 60 over 90 minus 30 minus 24 should give rise to 6. Now, if I calculate this together, I'll be having 60 divided by 6 to give rise to 10. Now, my value is equals to 10. Now, what is the unit of this mass here? The unit of my mass, don't forget that your mass is in gram. I want to find the unit of this. If my mass is in gram, and this one is in centimeter inverse, automatically, there is a value of 10 raised to the power minus 3 here. At the end, there is a value of 10 raised to the power minus 3 here. So I think that 10 raised to the power minus 3 should be included in your calculation. But we can just put it like this, okay? Sorry. There is a value here, which is, this one is not ordinary this. It is 30, sorry. I have 30 minus 24. That is 30 minus 24, everything times 10 raised to the power minus 3. Now, 30 minus 24 will give rise to 6. This will give rise to what? 6 here. So I should be having 90 minus this, which is 60. Why this one what? 6 times 10 raised to the power minus 3. Whereby I can easily get this as something 6, cancelling this. Then you'll be having 10 times 10 raised to the power 10. 10 times 10 raised to the power 3, sorry, which is equals to 10 raised to the power 4. That is the value that I should be having in that place, because if you convert this one here to the top here, I'll be having 10 raised to the power 4. Now, so from here, I should be having the unit of this, which is 10 times 10 raised to the power 4. The unit should now be gram over centimeter inverse. So in converting the centimeter inverse, you'll be having gram centimeter, whichever here I'll be having what? Gram centimeter. So you can return this gram back to kilogram. In converting it to kilogram, then I can have divided by 1000. Then I'll be having 1000 kilogram centimeter. That is the value. We divide this thing by 1000. Then I should be having 10 kilogram centimeter. That is our value, but you don't need anything to convert here. Just make sure that your value is exactly 10 raised to the power 4 gram centimeter. I think that's all about this. Then you can easily calculate any calculation given under it. I'm sure that the calculation that they will be giving you under this experiment is that you'll be asked to state the principle of moment. If you are not asked to state the principle of moment, another thing that I'm going to give to you is that you'll be asked to calculate, maybe you are given a question on the uniform meter rule, then you have to calculate for the mass of the body or the weight of the body. Thank you for watching this video. Please don't forget to subscribe to my channel and click on the like button to like my video, then share with your friend. Thanks.